Hi. I'm sure you guys are really, really sad that you're not in my classroom today because I'm giving the ACTs to some juniors. But doesn't mean a day of no work, of course, because you know Miss McMullen. So I just decided to make a video that you guys could watch and follow along and take notes in your notebooks. You will need a calculator and pens and your notebook today. All right. So why don't you go ahead and start by turning to the table of contents, and let's go ahead and add today's date, which is 2/21, and we are solving systems by substitution. And you're going to make sure what page. I left off on page 38, so I'm going to start on page 39. So I'm going to go ahead and add 38 right here, and I'm going to put starting 39 right there. Okay. Now, if you're wondering, wait a minute, that's very similar to what we just learned, solving systems by graphing. You're correct. This is just another method to solve systems. And of course, I know you're going to be asking me, why do we need to learn another method? And there's kind of a couple reasons. First of all, you may not always have access to a graph or to a graphing calculator, and you still need to solve a system. And this is a way that you could do it with just a typical everyday calculator that you have on your phone or something where it doesn't have a graphing ability. And also, there are times when the equations are set up in a way that solving it by substitutions will be faster than solving it by graphing. And then also, there are times when if you don't have a graphing calculator, the lines would cross at a spot that isn't exactly a corner. And so you wouldn't be able to know, well, is that 2.3 or 2.4? Because you can't really see exactly the spot. And so you would need to do it algebraically if it's not an exact whole number or integer to be able to know the answer. So there are times when you have to have a different method. So this is a method that will work. So we're going to start here on page 39. And we're going to label this solving systems by substitution. Okay, and like always, I'm going to start with a more difficult one, and then we're going to move on to something just a little bit easier. Okay. All right, so we're going to start with, let's start with this one here. So negative 8x minus 6y equals 0. And you have y equals 6x plus 22. Okay, so you have two different equations here. That's what makes it a system. And you want to know what x is and you want to know what y is. And like we said before, in order to figure out what x and y is, when you have two variables, you need two equations. You could graph both these, but in order, this bottom one here is really easy to graph. It's already in y equals mx plus b form. But you can see that this top equation here is not in y equals mx plus b form. So you would have to solve that one for y in order to be able to graph it. So maybe rather than solving that for y, there's another way to do that. Okay, so if you look at this, we know what y is. What is y? Well, y is this part right here, okay? So step one, right, and I'm going to write that off to the side here, is solve for one of the variables. It doesn't matter which one, solve for one of the variables. Okay? And you can pause this at any time that you need some more time to write, okay? Well, this y is already solved for this, okay? So this one's already done. One of the variables is solved for. This y is solved for. Now, could we have solved for this x? Sure. Could we have solved for that y? Sure. We could have solved for this x. It doesn't matter which one you solve for, as long as you solve for one of them. That's already done. And so we know that y is equal to this amount. Okay, so what we're going to do, step 2, is we're going to take and put that, substitute what the variable is equal to in the correct spot. Okay, you got to put it in the correct spot. What I mean for that is this is y, because that's what this says. Y is this. What I put in the red box is y. Well, this is also y right here. Do you guys see that? So what I'm going to do is I'm going to stick this in there in that equation. So I'm going to rewrite the equation. Okay, I'm going to do this, negative 8x minus 6, but I'm not going to write y. Okay, I'm going to put in parentheses. Okay, you're going to put it in parentheses. I'm going to put this right there instead. Okay, I wrote this entire equation, I only changed the y. I made the y this amount right here, because this amount is y. Now, you're going to see something interesting now. Now we only have one variable in this equation, and that variable is x. X is in there twice, but it's only x, and we can combine x's. When we have a problem is when we have both x and y, and you can't combine those, so you can't possibly solve for it. But now what we've done is we've made it so that they are all x's, and that means we can solve for it. So let's go ahead and solve this one. So step 3, right here, step 3, I'm going to put it right here, I guess, is line down, well, that's not spelled right, down the equal sign and solve. This is an O right here. Miss McMullen's bad handwriting again. Okay, so we're going to put our line down, our equal sign, and then we're going to solve. Okay, so in order to solve this, you guys may want to flip back, if needed, back into solving, right here, solving, you got solving equations, two-step equations, combining like terms, distribution, variables on both sides. All of these right in here, all these solving ones will help you if you get stuck, okay? So first thing I want to do is I want to look at my two different sides. Well, this side's 0. There's obviously nothing I can do there. So if I look at this side, then I can say, well, I can simplify. And the first thing you're going to want to do simplify is you're going to want to get rid of the parentheses. And to do that, we're going to need to distribute this negative 6 right here. So that's going to have to be distributed. Okay, so this negative 8 is going to, x is going to come straight down. Okay, this equals 0 is going to come straight down because we're not distributing to those pieces. So now we're going to do negative 6 times 6x. Put that in your calculator, you're going to get negative 36. Don't forget your x. And then negative 6 times 22. I'm going to need a calculator on that one. Negative 6 times 22 is negative 132. Okay, so we have gotten rid of the parentheses. So let's see if there's anything else we can simplify on this side. We want to make sure it's as simple as possible before we do any inverses, okay? So let's see. I see something else we can do. We can combine like terms right here. We can combine those two because they're the same. So we're going to add negative 8 plus negative 36. And that's going to get us negative 44 x's. I'm going to skip a line just so it looks a little cleaner. Negative 44 x's. Okay, this negative 132 is going to come straight down, and this equals 0 is going to come straight down. Okay, so I'm going to make my line go just a little bit farther down. Okay. So now, is there anything I can simplify here? Well, I have x's and I have a constant. They cannot be combined. Okay, and I can't simplify anything here. So now that I'm done simplifying the sides, now I'm going to do inverses, okay? This is where we have to do PEMDAS backwards. So we're going to add 132 to both sides. So finally, we're actually doing some solving. First, we had to simplify before we could even get to the solving. Okay, so we have to realize what crosses off because negative 132 plus 132 is 0. So all we have left over here is negative 44x, and then we have 132 over here. So then we have to divide by negative 44. Negative 44 divided by negative 44 is 1. So that's going to leave us with just 1x, which is just x. And then we need to do negative 132 divided by negative 44, and we get 3. So x is equal to 3. Okay? Now, remember when we got a system, though, what did our answer look like? You remember, go back over here to graphing. You remember our answer looked like this. It was an x and a y as a coordinate point. We don't have that yet. We only have an x. So that is a problem, okay? So we need our next step to be that we're going to substitute what this variable is equal to in one of the equations. Okay, just one of them. So right here we have this one is equal to 3. I'm going to box it in blue here because I don't want to box it in red because I've already boxed in red once. So I'm going to box this in blue. I've got x is equal to 3. Well, I need to come up here and do one of these equations, and I need to put 3 in there. I can put it here, or I can put it here. It doesn't matter because these are both x's. So this x should be 3, and this x also should be 3, okay? If I put it here, my y is going to be in the middle, and I'm going to have to solve. If I put it here, my y is already by itself, and I'm just going to do exactly what it says. So it's just kind of your preference. Do you like to solve, line down the equal sign and solve? You're going to want to do this one. If you like to just do exactly what it says and put it in the calculator, you're going to want to do this one. This one is my preference, okay? So that's what I'm going to show you guys, okay? So you're going to rewrite that equation. It doesn't matter which one you rewrite. Just choose one of them to rewrite. And for this x right here, we're going to put in a 3, okay? So we're going to put a 3 right there. Everything else is going to come straight down. Okay, straight down. The only thing we changed was the x. This is exactly like what you guys quizzed over not very long ago, where you were you had x equals 3 and you had an equation. You're just picking which one you're going to use it in. Okay, and then y equals 18 plus 22, because 6 times 3 is 18. So that is going to be 40. Okay. So something's not quite right, and I'm trying to figure out what it is. Oh, I see it right here. This was a negative 3 right here. Negative 3. Ms. McMullen caught my error because I realized it wouldn't work. So this is a good way to catch your error. And actually, let's pretend like this was on purpose. So if you're going to put this back up here and check it, you need to do one of these. Okay? So this one right here, for example, you have negative 8. And instead of x, you're going to put what you found, which was, at first we had plain 3. So let's put 3 in there. Minus 6. And then what we found? We found 40. Okay, and that equals negative 264, and it's supposed to equal 0. So we know we did something wrong because this should have equaled 0. When I put the amount for x and the amount for y in here, it should equal what it says it's going to equal, and it didn't. So then I have to go back and figure out what it was I did wrong. So right here, this 132 divided by 40, negative 44, it should have been negative 3, which makes this a negative 3, which makes this a negative 18, which makes this a 4. Okay, that makes that a 4, not a 40. So let's try it. Let's check. So we have negative 8, parentheses, our x amount is negative 3, parentheses, minus 6. Make sure you use a minus in between terms and a negative in front of terms. That's just the way the calculator needs it. You got to use the minus when it's in between terms, and when it's in front of a new term, you got to use a negative. You got to know the difference between those two for the calculator's sake, okay? It doesn't really matter in real world, but the calculators know the difference. So, and then for the y, we're going to put a 4 in. Okay, enter, and now we get our 0 we're supposed to get. So then we checked it. So that is step number 5. Check. And I'm going to just write that right here, what you put in the calculator. That's x right there, minus 6. This is y right here, equals 0. Check. We checked it. It is true.